Good morning, dear cadets. So, in the previous video, we have solved number of numerical problems on combination of resistors. Now, today we will learn very important effect of electric current, heating effect of electric current. You all know the examples of electric iron, electric heaters. When they are connected to the switch, when they are connected to the main supply, the heater becomes very hot and that will be used for heating the water. Similarly, electric iron, you use it for pressing the clothes. Now let us consider simple example. In simple circuits, we use resistors, and these resistors are connected to a source of voltage like a battery. The battery consists of combination of cells. It is basically the chemicals, the chemical energy that is utilized. The chemical reactions take place when the circuit is closed. The chemical reactions take place in the chemical cells, and that will develop the potential difference across the system of resistors. This potential difference will lead to the flow of charges through the circuit. The potential difference that is required for the flow of electric current is provided by this battery. When the charges are flowing through the circuit, it is ultimately the work is done by the battery in driving the charges. When the work is done in driving the charges, then the electric current, when it flows through the circuit for a certain amount of time, then what happens in the circuit? That is interesting thing. So continuously the battery has to supply the energy. What happens to this energy? This energy that is supplied in driving the charges through the circuit, in driving the charges through the resistors, will be utilized for doing useful work. For example, if you are considering a fan circuit, when you switch on the fan, the current flows through the fan circuit, and this current which is flowing through the circuit is driven by the supply, the source. The source not only does work in supplying the current, this in turn does work in rotating the blades of the fan. That useful work is being done. But if you use continuously the same fan circuit continuously for long duration of time, for example table fan, if you are using it continuously for 1 hour, 2 hours, 3 hours continuously, not only you are getting the breeze, the wind, but when you touch the surface of the fan on the other side, you will find it will be hot. How is this? That is, when you supply the energy, when the source is supplying the energy continuously in the form of voltage and in the form of current, some part of that energy is converted into, it is dissipated in the form of heat. So that is quite common experience. When the circuit is consisting of bulbs, fans, then bulbs convert that electrical energy into light energy. The fans convert that electrical energy into mechanical energy in the rotation of the blades, and we use it for getting the breeze. If, for example, the circuit is consisting of only resistors, then whatever the work that is done by the source of battery or source of voltage, entirely that energy is converted into heat. So we are learning about that heating effect of electric current. So I gave you example of electric iron, then electric heater. The electric heater and electric iron consists of that alloy. The coil consists of alloy that is called as nichrome coil. We have discussed about it in the previous videos. So when the current flows through that nichrome coil, it gets heated up. How do you account for this heat energy? That is, electrical energy is converted into heat energy. How do you account for this? So let us say that V is the potential difference applied across a resistor, so that the current I flows through that resistor. When I is the current flowing through the resistor, I is the current due to the charges that flowing through the resistors. If Q is the charge flowing, if Q is the charge flowing in a resistor by applying a potential difference, V, then amount of work done W by the source, amount of work done by the source means by the battery. So this is calculated as V into Q. V is the amount of work done per unit charge. So for actual amount of charge Q, the total amount of work done is V into Q. Right? Then if the charges are flowing for time t, if the charges are flowing for time t, then we calculate work done per unit time. Work done per unit time, we calculate it as power input. That is power supplied in the circuit. This is basically electric power. Electric power supplied into the circuit is given by W by T by definition. Then what is W? W is VQ divided by T. See, from this equation, V is the potential difference, Q is the charge, and T is the time taken. So Q by T gives us the current. Here, Q by T is equal to the current I. Therefore, power input P is equal to V into I. We get P is equal to V into I. But we are interested in the calculation of heating effect, heat energy. How do you calculate that heat energy? Now we are considering purely resistive circuits, where only resistors are there in the circuit, right? So when we use only resistors in the circuit, when we allow the current for a long duration of time, then that energy supplied by the source is converted into heat energy. That is what we are calculating, heating effect of electric current. I gave you example of electric iron, another one like electric heater which has the coil. So the power input now becomes V into I. But we want to calculate how much is the heat energy produced. So this electric energy that is continuously supplied is converted into heat energy. Therefore, I will calculate heat energy produced. Heat energy produced is basically the energy. Energy equal to power into time. Energy is equal to power into time. That is, I will write separately power into time. Power input into time. This power is nothing but electric power, VI. So VIT. So thus we get heat energy produced is equal to VIT. Heat energy I am going to symbolize as capital H. Capital H is equal to heat energy produced is equal to power into time. So power is VI. So VI into P. So where V is the voltage supplied by the source, like the battery, I is the current, and T is the time for which the current is supplied. Time for which the current is supplied. It may be 5 minutes, 10 minutes, or half an hour. So, for example, when you are keeping the electric iron will be used for half an hour, 1 hour. So, how much is the total heat that is produced? That will be calculated using this VIT. But using Ohm's law, what is V? Here, V is equal to RI. Ohm's law. So if you substitute this, we get therefore heat energy H is equal to V, substitute V, IR into I into T. So I becomes I square. So thus it becomes I square RT. This is the heat that is produced in a circuit consisting of resistors alone, like heater or electric iron. Okay. So this conversion of electrical energy into heat energy, which depends on these factors like square of the current, resistance of that coil, and the time during which the current is passed. So this is called Joule's heat effect or Joule's heating effect, or it is called as Joule's law of heating. So let me write what is Joule's law of heating. Look at this same equation I have written here once again. The heat produced when a current I flows through a resistance R for some time T is given by I square RT. I square RT. So this is called as Joule's law of heating, or the heat that is lost, the energy that is lost in the form of heat due to the current I and the resistance R is given by I square RT. Right? So this is the heat that is measured in joules. In SI unit it is measured in joules. So what is Joule's law of heating? Heat produced is directly proportional to square of current. Square of current, that is I square. It is denoted by H, and H is directly proportional to the resistance R, and H is directly proportional to time T. Here it is resistance. So from this it is quite evident that more the current that flows, more will be the heating effect, because heat is directly proportional to square of the current. Second thing, heat is directly proportional to resistance of the coil, resistance of the resistor, and heat is also directly proportional to time for which you have kept it for heating. For example, if you have kept the heater to heat the water, heating coil to heat the water, see, the heat that is produced depends on the time, whether you are kept for 10 minutes or 15 minutes or 20 minutes or half an hour. More the time kept for heating, more will be the heat that is produced. More the time kept for allowing the current, more the time you are allowing the current, more is the heat produced. So heat produced is directly proportional to square of the current, directly proportional to the resistance, and directly proportional to time t. Here the source voltage V is constant. Source voltage V is constant. So this is the equation, that is H is equal to I square RT. Let us solve some problems based on this. An electric iron of resistance 20 ohm takes a current of 5 amperes. Calculate the heat produced in 30 seconds. See here, an electric iron is there which is kept for pressing the clothes, and its resistance is 20 ohm. So R is equal to 20 ohm. And it takes the current I equal to 5 amps, 5 ampere of current, and it is kept heating for time t equal to 30 seconds. How much is the heat produced? So using Joule's law, heat produced, directly you can write H is equal to I square RT. So substitute the value of I, substitute the value of R, I square, 5 square. It is a direct product. Resistance 20 ohm and time taken 30 seconds. So everything is given in SI units, ampere, ohm, second. So heat produced will be in terms of joules. So many joules. So you can write 2 3s are 600 into 5 5s are 25. So 25 6 are 150. 15000 joules. So you can write therefore heat produced is equal to 15,000 joules. 15 into 10 raised to 3 joules, which is equal to 15 kilojoules. So this is how you need to solve the problem using Joule's law of heating. Now let us see the next problem quickly. Second problem. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volts. In a circuit, the heat generated is needed to be calculated. How? The total charge of 96,000 coulomb. Total charge is equal to 96,000 coulomb is transferred for an hour through a potential difference of the source. That is, potential difference of the source is 50 volts. So what is the heat generated? So heat generated, as just now we calculated, heat generated H is equal to the work done by the source in driving the charges. The work done by the source in driving the charges is V into Q. Work done per unit charge is V. So for this 96,000 coulombs of charge which are being supplied through a time duration of 1 hour. So work done is equal to VQ. This entire energy that is supplied is converted into heat energy. So V into Q. V is 50 and Q is 96,000. So if you work it out, 9 6 are 5 6 are 30, carry 3, 5 9s are 45, 45 plus 3 48. So 1 2 3 4, 1 2 3 4, so many joules. So this is the total heat that is produced in terms of joules. So you can express in terms of kilojoules. So if you write it, yes, 4800 kilojoules or 4800 kilojoules of heat is being produced. 4800 kilojoules, or in scientific notation we can write it as 44.8 into 10 raised to 1 2 3 4 5 10 raised to 6 joules. So much of our heat is produced when 96,000 coulomb of charge is driven in a circuit by a voltage of 50 volts. Voltage supply of 50 volts. Now I will give you one problem. Look at this third problem. If 100 joule of heat being produced each second, if 100 joule of heat being produced per second in 4 ohm resistance, find the potential difference applied across the resistance. 4 ohm resistance is there. What is the potential difference applied across this? When a heat of 100 joule is produced per second, so time taken each second, t equal to 1 second, and resistance 4 ohm. Resistance 4 ohm. What is the voltage supply? So in order to calculate the voltage supply, we need to know what is the current. How much is the current flowing? We don't know the current and we don't know the voltage. So first we can calculate the current using Joule's law. What is Joule's law? Joule's law states that heat produced H is equal to I square RT. So heat produced is given Joule, time taken 1 second, resistance 4 ohm. Just substitute these values so that we can calculate for I square. Therefore, I square becomes equal to H by RT. H by RT. Therefore, just substitute H. H is how much? 100. And resistance is 4. And time taken is 1 second. So 4 on the 425. So 25. Yes. I square is 25. Therefore, what is our I? Therefore, I is equal to square root of 25. That is 5 amp. So now you got it. The current flowing through this circuit is I is equal to 5 ampere. And the resistance of this resistor is 4 ohm. So what is the voltage? Apply Ohm's law. So now using Ohm's law, V is equal to Ri. R is there, V is there. See, Ri 5 4s are 20. Very simple. So 4 into 5. So that becomes 20 volts. Potential difference supplied to the source is 20 volts across the resistance. Now I will give you one problem. You should try it yourself. Yes. Read this problem. There are two conducting wires of same material and of equal lengths. They are of same material and same equal lengths and same thickness, same diameters. They are first connected in series and then connected in parallel in the circuit across the same voltage, across the same potential difference supplied by the source. The ratio of heat produced in the series and parallel combination would be, is it 1:2, 2:1, 1:4 or 4:1? Calculate it. In the previous section we have studied series and parallel combination, and these are of resistances of same values R and R. You can try this. And in the previous video I have given you the problem to practice. And nowadays I am not sure whether you are watching the videos, solving the problems or not. Please practice it. Otherwise, this topic becomes very hard. As and when the video is over, you need to practice whatever the problems I have done on the board, even the problems which I am giving you for practice, and go through the exercises through net. There are various types of problems in the net or in the any resource book, any resource. So source book, like number of source books are there. So please solve them and ask the doubts if you have any doubts. Thank you. Have a nice day. Bye.